All right. Hello to everybody watching in my data management class. I assume there's probably nobody listening to this, but if anybody is listening to this, today I'll be presenting my statistical investigation on the relationship between Canada's population, live births, and deaths from the year 2000 to 2024. So the main purpose of this investigation was to determine if live births in population or if deaths in population. I wanted to see which one of those had a stronger, like, because obviously births and deaths will affect population, but I wanted to see which one affected population more. So to answer my question, I found three tables on Statistics Canada, one on population per year, one on births per year, and one on deaths per year in Canada. And I copy and pasted the info into a Google Sheets document. And from there, I calculated the measures of central tendencies, the measures of spread. I made graphs like such as scatter plots, residual plots, histograms, box plots, just to really analyze these three variables. So population was my dependent variable, while live births and deaths were my two independent variables. So before comparing the relationships, between the independent and the dependents, between the independent and dependent, I first analyze each data set individually. So here's my one variable analysis. So I calculated mean, median, modal interval, IQR, range, and the standard deviation. I did not include the modal interval, range, or IQR on here as I didn't feel it was as important as these other things. So these three histograms display my the stats I found on each of the topics. As you can see, live births is very left skewed, and deaths is very right skewed, and population has a sort of mound shape. It's kind of hard to tell, but the peak is in the middle of the graph. Therefore, I said it was a mound shape. I also noticed that the spread, aka the standard deviation, on deaths was much higher than it was on births, and I found that pretty interesting. One important thing to note is that none of the data sets had any significant outliers. So yeah, so now I can move on to my two variable analysis. I also made box plots, but I didn't have them in the presentation as I didn't feel as I feel as I only needed histograms, and the box plots were just further proving my analysis. So here is my population versus live births. So as you can see, the scatter plot showed a moderate positive linear relationship. So as Canada's population increased, the number of live births generally increased as well. You see this by my line of best fit here, and how its coefficient of determination is 0.184, and I square rooted that to find the correlation coefficient of 0.43, which indicated a moderate positive linear relationship. Um, yeah, so the line of best fit here, it can be used to estimate the number of live births from the population. Although as you can see, it's not very accurate as there are a lot of points that are not on the line of best fit. That's just an estimate. If we had a stronger correlation, as you'll see with depths, then the points would be closer to the line of best fit. So next, how this is how we can improve the model. So first, I made a residual plot, um, and I wanted to see the biggest, most influential point. And I found, I believe it was 2020. Yeah, it was in the year 2023, where the live births were 352,644, which was 262. Sorry, which is 26,000 below its expected value. So yeah, so on the line of best fit, it was 26,000 below that. So on my new graph, this is the line of best fit equation. You can see, I'll go back a slide. You can see it's this is the old equation, 0.00279 plus 266,959, and this is the new equation. You can see the slope increases, and the coefficient of determination that also increases, meaning um our graph becomes our correlation it becomes stronger. So that's just the effect of removing an uninfluential point. It can cause our correlation to become stronger. So yeah, next I'll be looking at population versus deaths. As you can see off rip, you can see it's already a stronger correlation. You can tell by all these points here how they're nice and close to the line of best fit. And you can also tell by the correlation coefficient, which is 0.97. This indicates a very, very strong positive relationship. Um, so compared with live births, population is clearly a much stronger predictor of the number of deaths. So I forgot to mention something on the last slide. The z-score of this influential point, it was negative 0.63, which shows it wasn't that extreme of an outlier. But I forgot to mention that, and I thought I should mention it. I've already gone over everything here. So next, I did the same thing for this. I looked at the residual plot. As you can see on this one, there actually is one outlier. This guy up here, which was in the year 2022, it was 29,000, um, 29,000 above the line of best fit, and its z-score was 2.07, placing it at approximately the 98th percentile, making it much more unusual than the rest of the data. So after removing this point, the R-squared value turned from 0.936 to 0.956, just making our correlation even stronger. As you can see, our line of best fit matches the points even more. You can see this point up here, it kind of brought our line of best fit up, and these points were a bit further away. Same with these points down here. And just removing that, I went back a slide, and just removing that made every point is a bit different. So next, the correlation type between both of my graphs. I classified both of them as cause and effect. As for live births, obviously, live births directly contributes to changes in Canada's population because every time there's a live birth that occurs, the population will increase by one. So obviously there's a direct correlation there. And then population versus deaths. Um, so as population grows, there are more people living in the country, so the total number of deaths will generally increase over time. Well, there are also other factors such as immigration, healthcare, age distribution. These influence population, but the live births and deaths I think have one of the most major impacts on population. So finally, the conclusion. So in conclusion, both relationships, they were both positive, but the relationship between population and deaths was much stronger than the relationships between population and live births. So the birth model had a correlation coefficient of, sorry, I forget what it was, 0.43, and deaths had a correlation coefficient of 0.97. So that just showed how deaths were much stronger. So the residual analysis also improved both models by identifying influential points and producing more accurate lines of best fit by removing those points. So overall, this investigation, it just showed that population is a much stronger predictor of deaths than it is of live births. It has also demonstrated how statistical tools, such as one variable analyses, scatter plots, regression models, residual plots, and correlation, how it can be used to analyze real world data and draw meaningful conclusions. So that's my presentation. Thank you all for listening. If anybody did listen, uh, thank you. I don't know if anybody did. So this was very, I'll just stop talking. Yeah. Thank you for all listening.